Hello, differential equation students, and welcome back to 6.2. This is in Unit 5, okay? And this is the finish to the last problem that I had, right? We had this initial problem here, and I should have gotten down to this green part. And I believe on the last video I said, well, these are constants, right? And there's no constant over here, so those are going to have to be 0. Then all of this jazz, right? The summation of that whole thing is also going to have to be 0 because I have a 0x to the k sitting over here. All right, so when I go to set this thing up, what I'm going to do is I'm going to have 3c sub 0 plus 2c sub 2. That equals 0. Then I have k plus 2, k plus 1. C to the, or sub k plus 2 plus 9k plus 3 times the c sub k. And that also equals 0. Okay. Now, notice that I excluded this summation, right? The summation sign. I'm not too worried about it, and neither should you. Okay, don't worry about it too much. We're going to exclude it for now. And then what I want to do is I want to get the bigger c value by itself. So if I was going to get it by itself, that'd be c sub 2 equals, well, I drag over this 3c naught, and then I'd have to divide by 2, right? So I get c sub 2 equal to this thing. So c sub 2 I have in terms of c sub 0. And likewise over here, I want to get the bigger one by itself. So I want c sub k plus 2 equal to, well, I would drag that across. It would be a negative 9k plus 3. Of course, there's a c sub k here. Divided by k plus 2 and k plus 1, right? This thing here. So I have the bigger one in terms of the smaller one, right? K plus 2 would be bigger than this k, all right? Now, what happens is I'm not allowed to have a ton of constants, remember? In fact, I'm only allowed to have 2 arbitrary starting spots, okay? And we've hit that for a long, long time now. So we need to figure out like this relationship, okay, between our constants. And now we get back into this summation. I thought I had the purple one. Okay, this one here. Now we get into that and we notice that k starts at 1. At 1, right? Well, okay, then let's do it. So like if k equals 1, what would I have? Well, here that'd be c sub 3 equals a, okay, this would be 9 plus 3 is 12, so this is a negative 12. C sub 1 divided by, this would be 3, that would be a 4, so that's a 12 here. Oh yeah, this is a 3 times 9, that's 20. Sorry, no, this one's right. This 12 is, this 12 on the bottom wrong. Of course, you guys knew that probably. This is a 1 plus 2 is 3, and then 1 plus 1 is 2, so that's a 6 down here, right? And now, c sub 1, okay, I don't think I can do anything with that, so I guess this is just a negative 2 c sub 1, all right? And then what we're going to do is, that doesn't give me a ton of information on how the pattern looks. So I go again, right? K equals 2. So now it would be c sub 4 equals, okay, well, now if I put in 2 for k now, this would be a 18 plus that, that's 21, that's negative 21. C sub 2. Then on the bottom, I would have 4 times 3, that's 12. So then if I try to simplify that a little bit, I think 3 goes in, so that's negative 7. C sub 2 divided by 4, right? Now, this is the key here. I know that C sub 2, C sub 2 is this guy over here. Oh, so then really this part can come out and I can put negative 3 C naught divided by 2 in for it, which in the end then would give me a 20, well not, yeah, 21 over 8. And now I just have C naught. Okay, so I have a C naught and a C1 so far. Okay, well, let's go again. I don't really see a pattern yet. K equals 3, then I have C sub 5 here, and now when I appear up here, okay, try to take a mental snapshot here. So I got C sub 5, that's negative 30 on top, a 20 on the bottom, and then that's times C sub 3 here, which would equal, well, let's simplify it a little bit. This is negative 3 halves. Now C3, oh, we found out that C3, this, this C3 is equal to, oh, C3 is here, it's equal to this, right? So, oh, then I can plug in that negative 2 C sub 1. These 2's would cancel, the negatives would cancel, and I would just get a 3 C1. Now I have C1s, C naughts, C1s. I'm sure you can kind of see what's about to happen here. If I go through and now I do C or K equals 4, then I have C sub 6 equals, that would be a 39 on the top, negative 39, a 30, and then that's C sub 4. Of course, what am I doing? I'm plugging this in here, okay? And then that would equal, well, can I simplify? Yeah, that's negative 13 over 10. C sub 4, but I already know that C sub 4 is this. So then that's times 21/8 C naught. Just doing some canceling and things. I don't really think that there's a ton that, yeah, I don't think there's anything that goes into that, so I just got to multiply this thing out. That's negative 273 on the top divided by an 80 on the bottom, and then that's C naught. And you can kind of see the pattern. C1, C naught, C1, C naught, right? And like, I mean, I could do another one if I wanted. I can do another one. Okay, if I did one more, this is C sub 7 equals, this would be a negative 48 on top, this is a 42, C sub 5 down here equals, those do simplify, it's negative 8/7 C5. Oh, but we know that C5 was 3 C1, which then gives me a negative 24 over 7 C sub 1. Okay. Now, you don't have to do a ton of these. Okay. It looks like for me, I have 1, 2, well, really just 1 here, 2. If I can get this thing to stay. 3. I got 3 C1s and I got 3 C naughts, right? Okay. That's not terrible, okay? And even though you don't see this right away. Now you don't quite see it right now, but you will here. These were all K values, right? And at the start, we started with this premise that K or N was equal to this K plus 2. Like that was the biggest index that we had to change around so that we could make this big one here. And we had this general assumption that the form was going to be n equals 0 to infinity of C sub n x to the n, right? Well, if K is 1, right, if K is 1, then when I kind of plug back in, right? If I put this in, back in, that means this thing here is actually C sub n. Okay, so when I'm plugging this in, this C sub 3 is that Cn, which means this one is x cubed. Because it's a 3 here, that's a 3, that means that x to the n is a 3. And then this one would be, oh, that means C sub 4, oh, x to the n, and that means that this one's x to the 4th. Okay, and then so on, right? So then this one's x to the 5th. Then I have x to the 6th and x to the 7th. Okay, well, let's try to plug in these, right? And you can see that it bevels back and forth, C1, then C naught, right? So clearly I have C naughts and C1s. Well, let's kind of group all the C naughts together. So if I start with the C naught, I have this 21/8, or actually, yeah, 21/8, I see that one, okay? And that was x to the 4th, right? Now, we also have minus 273/80ths, x to the 6th. And then technically this would keep going, right? So that shouldn't be too far of a stretch. And on C sub 1, I got a -2 x to the 3rd. Then my next one would have been that 3. So then I have plus 3x to the 5th minus, oh, my 24/7 x to the 7th. And then technically this would continue. Now I've left these blank spaces here. And this is kind of the harder part to see. C sub, or C naught here, is made up here at the initial one here. That's x to the 2nd, right? Oh, okay, so I'd have to actually have that too. This has the C naught, so I factored her out. But then that's minus 3/2 x to the 2nd. Now there's one more thing sitting there. Now the other ones, do I have any C sub 1s laying around here? And I don't see any C sub 1s laying around. And that's okay, because we have to have a starting spot. And this is where we have a starting spot for each one of our constants. And for the C naught, we might as well make that 1. And then C sub 1, we're going to make that one x, because then now I have them all counted, right? 0, 1, 2, 3, 4, 5, 6, 7, so on. And then we keep bouncing back and forth. Now, we have these two here. Well, what does the answer usually look like? Well, it's usually this one plus this one, okay? And then this is actually our very first solved differential equation using power series. I do plan on trying to do at least one more in this section, but this definitely allows you to get a start on the homework.